Before going into the strategic planning process, what I'd like to do is very briefly give a summary of this field called artificial intelligence. What does it cover, and what are the implications for the typical leader? I'll begin our discussion by describing the history of artificial intelligence, and then four branches of artificial intelligence that are quite distinct. The question then becomes, why is everyone so excited about this? And because of the excitement, how do I develop a strategy in this space? Many history books that describe artificial intelligence go back over 2,000 years to describe how humans have constantly been looking for mechanisms that can make life easier, replacing human labor, maybe going back to the earliest pumps like Archimedes' screws. Let me fast forward to the 1770s when the Industrial Revolution took place in the UK. Basically, there were highly skilled weavers. With the Industrial Revolution, these weavers were largely replaced by steam-powered factories that mimicked the detailed intelligence of a weaver. Now, there were some protests, but eventually the textile industry boomed and the price of textiles plummeted dramatically. Now let's move forward to 1794, when Eli Whitney created the cotton gin. This contraption mimicked the human behavior of separating the fiber of cotton from the seeds, thus increasing the productivity of the cotton industry, and the cotton industry boomed. Move forward, Henry Ford implementing the production or assembly line. Typically, parts were moved around a factory with human labor. Using automation, factory productivity skyrocketed, the price of automobiles plummeted, and employment in the automobile industry increased. Now let's move forward to the 1940s. That's when ENIAC, the famous computer at the University of Pennsylvania, was invented. All of a sudden, computers could automatically count large numbers and tell people at the end of the day how many people are living in a given area. Now let's fast forward to the 1970s. What may be the single most important breakthrough in artificial intelligence was the electronic pocket calculator. Now, we're probably the only species that knows how to calculate square roots. Perhaps dolphins do, nobody's really sure. But either way, the productivity of office workers skyrocketed. How many of you today look at a pocket calculator and say, wow, that's awesome artificial intelligence? The truth is, no one does. This is called the AI effect. What today people call AI, 20 years from now, they'll just say, oh, it's a stupid little algorithm that helps a car drive. Many people overhype what is considered artificial intelligence today because it gives them access to increased capital investments. So, what is artificial intelligence and machine learning, really? Well, I like to use the distinction that many others use, which is the difference between strong AI and weak AI. Think of strong AI as pure science fiction, literally a machine which is a human being, versus weak AI. That's what all the people like me actually do. We only do very small little aspects of artificial intelligence, very weak. Just think of CP3O. If C-3PO was very intelligent, when he actually needed electricity or power, he would actually walk outside, maybe eat some grass, and create electricity. Right now, artificial intelligence hasn't even figured out how the hypothalamus of the brain works. The most primitive part of our brain, we have not been able to come up with an algorithm that imitates even that. So everything that we're working on should be and is considered extremely weak. That being said, there's two broad areas of artificial intelligence. The first one, most people call good old-fashioned AI. The second part is what some people might consider new stuff, despite it being over 50 years old. Let's go through each branch one at a time. The first one is automation and robotics. Think of that as machines. The second branch is more cognitive or symbolic computing, coming up with expert systems and things like that. Then comes the data scientist. That's computational machine learning. That's what most people talk about in the press today. Finally, there's machine learning control, a very old branch of artificial intelligence. This is how planes, for example, go on autopilot, imitating the intelligence of a human pilot. Now, let's focus on robotics. From a human resources point of view, this is largely dominated by engineers, industrial designers, people with backgrounds in physics and robotics, but also in computer science. What they work on are machines that replace humans in one aspect of life or another, such as automatic teller machines or welding devices, etc. The logic that these people use is largely based on physics, on efficiency, on likability, and they use a number of computer languages. In the second bucket, which is cognitive or symbolic computing, they largely rely not on engineers, but on linguists, geographers, mathematicians, the core fundamental subjects that we learn in college, plus a bit of computer science. This branch was often credited for the earliest expert systems, or chatbots, but more recently with writing poetry and high-end research reports. And people employed in this branch of AI have a number of computer programs that they actually leverage. The next area is extremely important as it actually relies and leverages modern Python and R programs and inexpensive machinery to create some wonderful results. This is the area of computational machine learning, largely dominated by people with titles like marketing scientist or data scientist or management scientist. These folks are developing models that can help us forecast, classify, do machine translation using data-driven algorithms, and we'll discuss those in more detail later in our videos. The last area, machine learning control, is also quite old, but very important. Imagine you want to have a system that automatically minimizes costs or maximizes profits. That's called machine learning control. This has been dominated by people with backgrounds in operations research, industrial engineering, management science, and computer science. It is used all over industries for air conditioning systems, autopilots, etc. This area relies on hard mathematical formulations, typically in the form of dynamic, linear, integer, or geometric programming, etc. Many different computer programming languages are used by this group as well. If you look closely, you'll notice that Python and R are across all four branches of artificial intelligence, hence their popularity. So if many of these algorithms are fairly old, why is everyone so excited right now? Well, it turns out there's been a confluence of two major things. The first is people playing video games have demanded higher and higher end rendering of their graphics. People who play Grand Theft Auto, for example. Those machines relying on graphics cards could be repurposed for Bitcoin mining, leading to what? A huge demand and turnover in the graphics card industry. NVIDIA, creating something called CUDA, allowed those graphics cards to be accessed by R and Python programs. Hence, people could now use relatively inexpensive machinery to run very computationally intensive software. So we have easy access to advanced machine learning. The entry barriers have plummeted. Anyone can start up an AI company. Venture capital is flooding in. All that you need now is a good idea, the right skills, and a good strategy. Key ingredients to all of this has been Python and R. Emerging about a quarter of a century ago, these two languages emerged to be very popular amongst academicians and practitioners in this space. More recently, Python has been adopted by many organizations seeking to exploit deep learning algorithms. The communities around these two languages are very robust and actually very friendly and generous with their insights. So, what are the largest challenges to organizations that want to leverage these new tools? In my mind, it's a gap between the leaders who are driving implementation and those who are actually the implementers themselves. So what we're going to cover is not just the strategy of developing great AI-based ideas, but also how to work with the implementers and understand their perspectives in solving core problems. And if you happen to be an implementer, what we'll focus on is how to present your findings to leaders of a team so that you can have maximum impact. Now, why is this conversation so difficult? It's not because the technology is brand new, although some of it is. It's largely because of the jargon. In traditional strategic planning, you start with your objective. You want to know what you want to achieve. In the world of information technology, you build to purpose. And then what do? You audit the starting position. What data do I have? What software is available, etc. This leads to a number of algorithms that are largely unfamiliar to strategic planners. Strategic planners then go through a phase of modeling, trying to understand why the data vary from one geography to another, from one salesperson to another. In the world of artificial intelligence, this leads to a number of models such as Markov chains that again are unfamiliar. After that, the strategic planner looks for options. If I forecast the future, what are the things that I can possibly do? In the world of strategic planning, This is quite normal. In the world of machine learning, this leads to a number of models, including deep learning models that leverage neural networks, again unfamiliar to typical strategic planning. And finally, I want to optimize. Machine learning control is very well understood in some domains such as operations research, but largely unknown to many others. The process of planning, therefore, gets clouded with a lot of jargon. And it gets even worse. If you invite an academic to the conversation, they'll start using words like motivation, descriptive, explanatory, predictive, and normative. How do we resolve the problem of strategic planning and jargon? My answer to that question is, well, you cheat. I'm going to give you a little bit of a hint about what the professionals do. Suppose you're in a strategic planning process and someone says, I think we ought to use kriging. And you're going to say, what in the world is kriging? Now, before you have your next meeting, I'm going to give you a little hint. You go back to your office, and what do? Step one, you go to YouTube. I'm not kidding. You go to YouTube and you watch the absolute shortest one you can find. And then what do? You watch the next shortest one. And you keep repeating that until you get to the MIT and Stanford videos. Okay, step two. You go to GitHub. You simply type in the word kriging. And what are you looking for? To see if there's any code there. If there is code, then close the window. Don't analyze the code. That's for later. Just know if code is there. Step three, you go to Stack Overflow. Go there and just type in the word kriging and find out if people are talking about what you learned on GitHub. Just see if people are friendly. Are they nice? Are they saying if the code's awesome or not? So what's happened is you've spent from about 9 o'clock in the morning to noon, and you've kind of gotten the basic vocabulary of the tool. You'll realize it's actually not all that complicated. When you get back from lunch, then what should you do? Maybe check out a few researchers. For example, you might go into a database like researchgate.net or archive.org and try to understand who's researching this area just to get the names of important people that are out there and some of their latest ideas. And then what do? You go to your favorite search engine and you simply type in kriging and type in applications. Try to find companies that are already using this and get background information. Now you have the jargon that your machine learning people have, and machine learning people now kind of understand what that algorithm is and how it can be used to actually increase the performance of an organization. Okay, so we realize that it's not about understanding what a tool is. You'll never have enough time to go back to grad school and learn about every single tool. The good news is, it's easy to pick up. So your only real problem is coming up with a worthwhile objective and then figuring out how to lead and manage a team that will make it happen. You only need to know just enough to be able to engage with that team or to report to others within the organization. So what we propose is a very rigorous and structured strategic planning process. The best practice is to simply start with an objective and then choose the best course of action following a 5-step process. A bad idea is to read about artificial intelligence and say, wow, chatbots are cool. Let's build a chatbot, and then only realize later that it actually doesn't increase profitability. Or build a data warehouse and then one day ask, I wonder how we can monetize it. Or hire a vendor to do an AI project for you, only to realize later that given your objective, you probably could have done it yourself and maybe very quickly. Okay, there you have it. Artificial intelligence is a very old field. It's easy to pick up on the methodologies and the algorithms, and it's inexpensive to start up in this space. So what's the real problem? The problem is trying to find an application that actually can solve a problem. In order to do so without spending too much money, we suggest that you become very strategic and systematic about it. And that will be the subject of the next videos.